Okay, gang, today we're going to talk about conditional probabilities. So I'm just going to jump right in and you can follow along and take notes as we go through. The objective today is to figure out how to find the probability of an event given that another event has already occurred. So here's an example. You draw a card from a deck and look at it. You tell us that the card is red. Knowing that, knowing that the card is red, what's the probability that the card is a heart? Well, since the card is red, we know we're not interested in all 52 cards in the deck. Since the card is red, the new sample space is only 26 cards, right? We basically know there's 26 cards that are red, 26 red cards. What card would be considered a success? Well, we're interested in hearts, so hearts would be a success, and there's 13 of those. So what's the probability that the card you're holding is a heart? Well, we know it's one of those 26 red cards. There's 13 of those cards that are hearts. So the probability then is 13 out of 26. The way you write this mathematically and in probability terms is the probability of a heart. That line there is a given statement. So it's saying probability of heart given we know it's a red card. The given statement makes all the difference because the given statement changes the sample space. Instead of us being interested in the entire deck of cards, we're only interested in the red cards. And there's only 26 of them, which means our probability would be 13 hearts out of 26, which is 1/2. And that, in a nutshell, is conditional probability. So let's do a few more examples. 4 cards have been drawn from a deck of cards, and they are all clubs. What's the probability that the next card will also be a club? So here's the way we write it. The probability that the next card is a club given, that's what the line means. Remember, the line means given. We've already drawn 4 clubs. So the first question is, how many cards are left? We've already drawn 4, so there's not 52 cards in the deck anymore. There's only 48 cards left in the deck because we've already drawn them. And now we want to know what's the probability that the card we draw is a club. Well, how many clubs are left? Remember, we started with 13, but we already drew out 4. Those 4 have already been drawn. That means there's 9 clubs left. So the probability then is 9 out of 48. All right, let's do another one. If one card is drawn from a deck, what's the probability that it's a queen given it's a face card? So we know it's a face card. So we have to think, well, how many face cards are there? You may remember there's 12. There's jacks, queens, and kings. 4 jacks, 4 queens, 4 kings. Those are face cards. We know it's a face card. Therefore, the bottom has to be the face cards, 12. How many of those 12 are queens? 4. So 4 out of 12. Next one, probability of a 10 given a spade. We know it's a spade. So what you have to ask yourself is, how many spades are there? There's 13. So we know it's one of those. It's got to be one of those 13. What's the probability it's the 10? Well, there's only one 10, so 1 out of 13. What's the probability the next card is a red given we've drawn 2 spades? So we know we pulled out 2 spades. How many cards are left? Remember, there's 50 in a deck. We pulled out 2, so that means there's 50 cards left. Of those 50 cards, how many are reds? Well, there's 26 reds, and we haven't pulled out any reds. We've only pulled out 2 spades. So that means there's still 26 reds left. So 26 out of 50. Okay, do a table. We've seen this table before, so I'm going to add them up going across again. I get 10 to get 25, 11, 19, I'm going to add 10 and 25 that way. And that's 11, and that's 13, and that's 17, and that's 9, and there's 50 total. I always like to do that before I go any further. So it's asking, what's the probability they play baseball given they're males? That means we're not interested in the whole table. We're only interested in the males, the row that has males in it. How many males are there? 25. Of those 25 males, how many play baseball? So I would look across here and I would see, if I'm only interested in this row, these 6 people play baseball. So the probability then is 6 out of 25. All right, I'm only interested in this problem. I'm only interested in the males. It means I'm only interested in those 25 people. And how many of those 25 people play baseball? 6. So the probability is 6 out of 25. Probability of female given soccer. So I'm only interested in the soccer players. All right, this is the ones I'm interested in. So there's 9 of them. Of those 9 soccer players, I'm only interested in these people right here. Of those 9 soccer players, how many are females? 7. 7 out of 9. That's your probability. 7 out of 9. Okay, my marks here. Okay, and then next one, probability of male given basketball. Right, given basketball. I'm only interested in the basketball players. There are 17 basketball players, so 17 goes on bottom. Of those 17 people, how many are males? 9. 9 out of 17. That's the given statement. Probability of soccer given female. Probability of soccer given female. I'm only interested in the females. That means I'm only interested in those people right there. So there's 25 of them. How many of those 25 play soccer? That would be these people right here. 7 out of 25. Anytime you have a given statement, it changes the sample space. It changes the number on the bottom. Okay, that's it. So when you come to office hours this week, we're going to do some practice problems together and hopefully explain this a little bit more. And then you're going to do some practice problems on your own. And then you have a homework assignment at the end of the week. So good luck.